All right, here we are back again, part 2, and we're going to do an example. So there's 2 examples. If you don't have room, you can put it on the response side, because it is a response to that data. All right, I want you to find the standard equation. So that's one of these 2 guys. So find the standard equation.
What should I title this page?
The whole thing is parabola.
Okay.
Find the standard equation, and here's the clues I'm going to give you. The vertex of this is at 0, 0, the origin, and the focus is at 2, 0. All right. So let me go into training on these kind of problems. You'll find when they're asked this way, there's very little math, just a little sketching, and you can pretty much come up with it. So once you get the question down, I'll start it. Find the standard equation when the vertex and focus are known. Got it yet? All right, so let's do a sketch of that. That'll be part of our answer. And we're going to mark the vertex. So go ahead and hit the origin, 0, 0. I'm going to put a little V there so I can see that that's the vertex. You have to keep going back and forth.
Should I focus on that part? Or?
Yeah.
Okay.
We can go back. She should have that written down, so she should be all right.
Write it down quick. Okay.
Yeah. All right. So here's the vertex. Go ahead and draw your coordinate plane and mark the vertex that's given. And I mark it with a V so I can remember. And find the focus, and that's at 2, 0. So that would be, I'm going to move my marking on the other side, because 0, 0, and V for vertex, and 2, 0 is my focus. Now, one thing about a vertex and a focus that's always true is the vertex is always on the parabola and the focus is never on the parabola. It has a function, but it's not actually on it. Need to adjust a little.
It's like a tilted.
I'm sorry, it's a little crooked. Our stand isn't working like it should, so you might have to tilt your head sometimes. So, can you visualize the well, I'll teach it, and then you'll be able to try it on your own problems. So the vertex is here, so that tells me the parabola is either going to look like that, or like this, or like this, or like that. So the vertex is right on that highest, lowest, or most left or right point, the extreme point. But because the focus is here, we know that the answer must look like this. Notice the parabola envelops, a new word, envelops, maybe it's on the SAT. It comes around, it doesn't touch, but it guards or envelops the focus. So that because of its placement here, I know that the parabola has to look like that. So right away, I can identify whether it is horizontal or vertical. So which is this?
Horizontal.
Right, because the opening went to the right. So if it goes right or left, the opening, then it's horizontal. If it goes up or down, then you know that it is a vertical. So I'm going to go over here. You don't have to change the lens direction. I'm going to go over here where I gave you the vertical equation and the horizontal equation. So this is the vertical one up there. So I'm going to write it down. Y minus h quantity squared equals 4p x minus k. All right, so I've identified which it is, horizontal or vertical, and wrote down the corresponding equation. So now, in my final answer, x and y will remain, but I've got to find a number for the h, the p, and the k. From what I've said already, do you have any ideas, Bailey, what any of these would be?
The P would be 2.
What?
The P would be 2.
Alright, the P would be 2 because the distance between the vertex and the directrix is going to be P. So look at this, the distance from here to here. So let's go ahead and put in a 2 there. So that'll be multiplied by the 4, and I'll come back and do that in a minute. What about the H and the K?
It would be 0 and 0.
Pardon, right. So on this one, there is no H and K because the origin is also the vertex. So we end up with y squared equals 8x, and that is the correct answer. So that's not too bad. Any questions about that?
No.
All right, very good. All right, the other kind of question that's going to come at you will be a little more challenging than that one. So it looks like you have 4 of this kind, if I'm reading these right, and there'll be 3 of the kind I'm going to show you now. A little more mathematical. So let us look, we're going to basically go the other way. I'll take a worst case scenario where we have all kinds of fractions and things. Let's take that one. And here we are in the center of the boards. That's in view, right?
Yeah.
All right. Here's the next type of problem. I'll leave the information up here. I don't think I need this any longer. Here's the problem, and the command this time is to basically find the vertex and the focus and graph it. So basically graph it. To do that, you need to find the vertex and the focus. All right, so studying this equation, I see an x squared term. So basically, does the x squared term show up when it's a vertical or a horizontal?
Vertical.
All right, so you notice in the original, the x was in a squared term, so this must be a vertical. So I'll write that down because I've identified at least one aspect of it. So I'm going to write down the equation of the vertical, x minus h squared equals 4p y minus k. And I'm going to work with that. I'm going to force this equation to look like this. And when it does, I'll have my vertex and I'll have my focus. So all this is training you how to get this to look like this. All right, I want to take all the x terms and put them over here and everything else and put it over there. So I'll begin by doing that. All right, I see some fractions floating around and they're kind of pesky. What can I do mathematically to just get rid of them all?
+1/2, sorry.
Go ahead. You can catch up and then answer the question.
Okay, what was it?
I see fractions floating around and they are kind of pesky. So what can I do mathematically?
Multiply it all by 2.
Pardon?
Multiply it all by 2.
Everything by 2. So would you read the equation as you rewrite it, actually multiplying each term by 2?
Okay, so x...
Oh, I lost my...
Squared.
Squared, sorry. There you go.
So x squared plus 2x equals -2y plus 1.
Right, all right, that's a little nicer to work with. So I recommend clearing the fractions when it's possible. All right, now I need this side to look like this side. So we have to do what's called completing the square. Mm-hmm. So we've done that enough in our math past. So what number do I add? Do you recall how to tell that will complete the square on the left? It has something to do with that number. It's always half of that number squared. So what am I speaking of?
Just 1. Right,
half of that squared is 1. But I can't just go in and add a 1 on one side without adding it on the other. So over here it becomes -2y plus 1 plus 1, or plus 2. All right, we're almost there now. So do you recall how to write that as the we added a special number, so it is a perfect square. So what two terms squared give you this expression?
X minus 2 squared.
Pardon?
X minus 2 squared.
It's plus.
X plus 2.
Right. It's always going to be the square root of that sign. And that's where the plus came from, and the square root of that.
Okay.
All right. So now I've written that as a perfect square. Do you see how it's starting to pattern after our desired formula? Okay. What can I do on this side to make it look more like this? Like I see a set of parentheses. I don't see a set of parentheses here. What could I do with that?
Take out a 2.
Right. I'll take out a minus 2 just because I like the y to be positive. So what remains behind?
Y minus 2. Or
Right.
y minus 1.
Right. Y minus 1. All right. Oh, actually, I think I made a boo-boo somewhere. Maybe I made the boo-boo on my paper. I had a plus 1 once I pulled out the minus, but that's not true. I think I probably made it. I probably did it wrong on my paper. So I agree with you. Y and then a minus 1. That's what you said, right?
Yes.
Okay. Now can you see we are matching here? All right. The only thing is, you know, this matches this matches this, la la la, la la la, la la la. But this 4 and this P match this. So we're going to have to, in our minds, change this and so that there's always a 4 in it. So what can I multiply 4 by to get a minus 2?
Negative 1/2.
Or negative 1/2. All right, so that's the grand finale, and I'm going to go over here with it because that's where I'm going to graph it. So I have x plus 1 squared equals 4 times minus 1/2, which is equivalent to this 2, but I needed a 4 in our form, and then that's followed by a y minus 1. That is us. Okay. All right. I'm going to leave you off there, and I think you can find your H and your K, and this is your P, and I showed you how to actually graph it from that point on the previous example. So let me reduce this work because I thought we'd have plenty of time in class. So let's just do 2 of these and 2 of these. So we won't be too strenuous on our testing day. Can she see that change? That is on this paper, and I'll shine a light on it for her.
Okay, thank you.
All right, so numbers 22, 23, 34, and 35. Let me turn the light off and get that real quick. Can you put the packets away for me? Mm-hmm. All right. All right, 22 and 23. 22 and 23 are right there. And the command was find the vertex, focus, directrix, and sketch it. So again, 22 and 23. Can you grab the lights? Yeah. And on the back is number 34 and 35. Where's that? Sorry. Where's 34 and 35? Oh, I'm over the wrong side. Here's 34 and 35.
And like every day.
And the command there is find the standard form of the equation. All right, that's all for us. Goodbye.